Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, thank you for being here today. My name is Chandra Restu Andhika Putra and my student ID number is 2505080064. Today, I will present a topic that is fundamental in the field of electrical engineering, especially for those who are beginning to learn about basic circuits. The topic of my presentation is direct current and series parallel resistor circuits. This presentation will guide you through the essential principles of DC electricity, how resistor works, and how they behave in both series and parallel configurations. My goal is to explain you these concepts clearly and thoroughly so that they can be easily understood by beginners as well as useful for more advanced learning. Okay, Introduction to Direct Current (DC). Let me begin by explaining what direct current or DC actually is. Direct current refers to the flow of electric charge in one constant direction, unlike alternating current or AC, which periodically reverses direction. DC remains steady and unidirectional over time. DC is produced by various sources such as batteries, solar panels, and DC power supplies. Because of its stable and predictable nature, DC is widely used in electronic device, control system, communication equipment, and low voltage application. Many of the technologies we use every day, like smartphone, laptops, and LED lighting, operate using DC power. Okay. Next is basic concepts in DC circuits. To understand DC circuits, we must first understand three fundamental electrical quantities. Number one is voltage. Voltage represents the electrical potential difference between 2 points. It can be thought of as the pressure that pushes electric charge through a circuit. Number two is current. Current is the flow of electric charge, measured in amperes. It tells us how much charge is passing through a conductor per unit time. Number three is resistance. Resistance is the opposition to the flow of electric current, measured in ohms. All materials have some resistance, but resistors are components specifically designed to provide a controlled amount of resistance. These three quantities are governed by Ohm's law, one of the most important relationships in electrical engineering. V equal IXR. This formula allows us to determine the voltage, current, or resistance when the other two are known. Okay, next is understanding about resistor. Resistors are essential components in almost all electronic circuits. Their primary functions include controlling the flow of current, dividing voltage across different parts of a circuit, protecting components from excessive current. Resistors are measured in ohms and come in several types such as fixed resistors, variable resistor potentiometers, thermistors, which change resistance based on temperature. Their versatility makes resistors indispensable in circuit design, from simple LED circuits to complex digital systems. Next is series resistor circuits. Now let's look at how resistors behave when connected in series. A series circuit is formed when components are connected end to end, creating a single path for current to flow. In a series circuit, the same current flows through all components. Total resistance is the sum of all individual resistance. RT equal R1 plus R2 plus RT. Voltage differs across each resistor depending on its resistance value. Series circuits are used when equal current is required through all components, such as in Christmas lights or sensor networks. Next is parallel resistor circuits. Next, we have parallel circuits. In these configurations, components are connected across the same two points, forming multiple branches. In the parallel circuit, each branch has the same voltage. Total resistance is always lower than the smallest resistor value. The formula for total resistance is 1 per RT equals 1 per R1 plus 1 per R2 plus 1 per R3. Current splits among the branches, with each branch receiving a portion of current based on its resistance. Parallel circuits are common in household wiring, where each device must receive full voltage independently. Okay, next is analyzing current and voltage in DC circuits. To analyze DC circuits, the process usually involves 1. Simplifying the circuits by reducing series or parallel groups of resistors. Number 2 is calculating the total resistance or RT. Number 3 is using Ohm's law to find the total current. 1 equals V per RT. Number 4 is determining voltage drops in series circuits, current distribution in parallel circuits. This systematic approach ensures accurate and efficient circuit analysis. Next is electrical power in DC circuits. Power is another important concept in DC circuits. It tells us how much electrical energy is being consumed or converted per second. Some useful power formulas include P equals Vxi, P equal 1 to R, P equal V2 per R. Understanding power helps us choose the correct resistor ratings and prevents components from overheating. Safe design must ensure that components operate within their power limits. Okay, next is conclusions. To summarize the presentation, direct current or DC provides a steady and unidirectional flow of electrical charge, making it essential for electronic devices. Understanding voltage, current, and resistance is fundamental before working with circuits. Resistors are crucial components used for controlling current and dividing voltage. Series circuits have a single current path, while parallel circuits have multiple branches with equal voltage. Ohm's law is the key to accurately analyzing DC circuits. Power calculations ensure that circuits operate safely and efficiently. These principles form the foundation of electrical engineering and are critical for designing more advanced circuits and electronic systems. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.